Hello. This is Junichiro Horikawa, and this is the 97th episode for Houdini Algorithmic Life. This is the weekly tutorial live for Houdini. And the topic for today is to create this so-called hyperbolic surface by using a physics simulations, in this case, a Vellum system in Houdini. To create this kind of a hyperbolic surface growth simulations. Makes it look like kind of flower-like shape, or the one that you use in bathroom. Alright, so I'm going to show you step by step how to create this setup, and with possibly some flexible system to make it to be able to create some kind of variations using different parameters. I mean, this is one of the results that you get out of the simple like setup, but by making the system itself flexible, you can create many types of shapes using different parameters for constraints and so on. So that's what I would like to try out today. All right. So before get it into the detail, what I would like to show is, first of all, how do you make the initial geometry, which always, for myself, starts from disk, and the graph network of this disk is kind of a special. It starts with a polygon with a set number of edges, and then for each edge on the first circle, you create two additional triangles on the next step, meaning you are adding two edge per one edge. If the previous edge has like 16 edges for the first circle, then the second layer of the circle will have 32, and then the next one have 64, 128, 256, and so on. So that is going to be the structure of this disk, which I am going to just use the the Vex to create from scratch using code. Probably you could do this with using only nodes, but that might takes too many nodes to be connected, so I'm just going to use one single Vex attribute wrangle to do this. Right. Then after that, what I'm going to do is to set the constraints for these short edges, right? These edges, to make these lengths become the same over time using this Vellum solver. So by making to try to grow these short edges to the same lengths as the first one, it will eventually create this kind of shape. You see that slowly those edge lengths is growing over time, and by just doing that and by using the Vellum close constraints, it will just create this shape. That's that easy, and that's pretty much about it. So the system itself is pretty simple. You just need to create the structures as well as some constraints, conditions, and that's pretty much it, right? So that's what I'm gonna do. And the parameters you might be able to change is like the ratio of these short lengths, short edge lengths between the edge which is closer to the center to the outer edges. Or you could also try to change the longer edge lengths as well to see the differences, right? That might be interesting to see the different results. So let's try. All right, from scratch. 三波換算ありがとうございます。So let's do this. I'm gonna set the background to dark, and as I said, I'm going to start to create the base disk shape first of all, right? Using attribute wrangle, right? Starting from geometry, and let me also save this. Okay. Attribute wrangle. I'm gonna change this to detail because I just wanna make once, and starting with a initial disk. Alright. So first thing first, I'm gonna try to what I need as a parameter is number of layers and the initial division numbers for the first set of polygon or circle. So let's give that as a parameter. First of all, layer, and the division number. Now let's start by creating the first circle, the first polygon, with specific radius, which is going to be used as the longer edge lengths. So I'm gonna name it as radius. That could be any name, or maybe it might be easier to understand by saying long lengths, longer edge lengths, right? Okay, so we have three parameters. So first of all, we want to create the first set of polygon. Oh well, ハカンさんありがとうございます for super chat. Let's do this. So this division is going to be used as the number of edges for initial polygons. So let's give a for loop. And try to create the first polygon by creating the first set of points, which could be calculated using trigonometry. So in order to do that, you need to first of all calculate the angle for each point, which is going to be I divided by division multiplied by pi by 2. Pi by 2 is 360 degrees. So for each iterations, you get the angles dividing the pi by 2, the 360 degrees circle angle. And for each angle, I'm going to create the position for the point using trigonometry like cosine and sine multiplied by the radius. Okay, so this is going to be the point position for the disk. Set 0, 0, okay. I don't need this. Alright, now let's try to create the point. And where's it? Do I see it? Nope. That is because I didn't set any parameters. So let's set the long lengths to 1, layer to some random numbers, and divisions to some random numbers. And I can see that by changing the division numbers, I am seeing those points created. So if I set to 6, I have 6 points, so that's good. So divided, creating a 6-side polygons, which is hexagon. Okay, let's try with this hexagon. Now, what I need next is to create the polygon, right? From this, and I want to create a triangular shape for each edges, like that. So let's do that. So in order to do that, I do need to know the center point. I do need to have additional center point positions or center point geometry in order to connect with other points to create a triangle shape. So let's create that as well. I'm gonna name it as center point, and this is going to be set to origin position, so 0, 0, 0. All right. Now that I know the name of the center point and the point, I am ready to create the triangle shape. But in order to do that, I do need to know the next point number to the current one. So I am first going to create a array, which is going to have store all the point numbers after I created the point. Like this. Oops. Right. Now, after I have created those points, I am going to run additional for loop after this to access the points which is inside this array. So for okay, PT is PTS. Right, then what was it? I do need to know the next point number, so I'm going to say I plus 1, which is going to be the next point number stored in the array. But there is a possibility that this number goes over the length of point number point array, so I'm going to reset to 0 if it goes over the size of this point array by calculating the modulus of the length of the point number. Okay. Okay, so this should give you the point number point number 1, point number 2, and I already have the center point, so by connecting those points together, I should be able to create a triangle. So let's do that by calling add prim poly, and starting from center, and pt1, pt2, let's see, oops, send pt. Okay, here goes. The order seems good. So so this is the first set of geometries that I'm going to create. Right now it's just changing the side numbers by changing this division numbers. Now what I want to do next is to create the second or the other set of layers by adding 2 edges multiplied by 2 edges from the previous polygon. So if the first set of polygon has 16 edges, then the second layer should have 32 edges and connected with triangles. All right, so that's what I would like to try out. And to do that, let's start from just by adding additional second layer to see how we can do that, right? Hello everybody. Thanks for all the comments. Is it possible to create a Calabi-Yau manifold shape in Houdini? So if possible to make... I think I got that kind of request some time ago. Let me see what that shape looks like. Calabi-Yau manifold. Nice. Yeah, I would definitely want to do this. Yeah. I'm gonna look into this to see how I can create this in Houdini. Then, yeah, I'll try to create it as a tutorial sometime. Okay, thanks for all the comments. And where were we? So I want to add additional layers to this. So since I have this parameter in order to add extra layers, so let's use this with additional loop somewhere on here. And overwrapping these for loops. Now currently I didn't use any information n inside this, so I am just creating the same triangles like several times by 5 times. Let me set this to 2 for now because I just want to create the second layer. Okay, so let's see how I need to change these structures in order to be able to use it for the extended layers. So the first set of layers, after we have created this first set of layers, we have this array which is set inside this PTS. Okay, now what we want to have next is the second set of points, okay, in order to create additional triangles. So let's call this PTS1 and changed everything that corresponds to that. And we are going to create a additional array called PTS2 so that we have 2 set of arrays. All right, like that. And in the second loop, when the n is equal to 1, we want to make we want to make the maybe the first set of point set could be equal to PTS2, and the PTS1 could actually be just the array containing the single center point, which is this one. That would make more sense, I think. So let's do that. I'm going to change all of those PTS1 to PTS2. Okay. This one, PTS2. All right. And for PTS1, I am just going to contain the center point inside. Like that. All right. And for the PTS2, the initial points could be empty for now. And for a array for inside the for loop, what I need to do is to first of all this division number is actually the number of points, but it's going to change based on the number of layers or number of iterations. So if the n is equal to 0, then the division number will be division multiplied by 1. If the n is equal to 1, which means if we are in the second iterations, then the division number will be division multiplied by 2. And the next loop will going to multiply by 2 again, and so on. Okay, so with that info, we might need to store how many number of points we have for each iterations. So I am going to create another variable, which is going to be used as the current division number, starting from div. And let's replace this with current division. All right, then after I have calculated everything right here, what I want to do for this current division is to multiply this by 2 to use it for the next loop. Okay, so in the next loop, we're going to have a size of the array multiplied by 2 from the previous array. Okay, that should make sense. And also for the next loop, we want to set the PTS1 to the current PTS2, meaning if this is the first iterations, the PTS1 is these points and PTS2 is this point, but in the next iterations, this point will be PTS1 and the next layer will be PTS2. So for the next iterations, I want to replace the PTS1 to PTS2 after all the calculations done in the first iterations, like that. And then I think we are ready to create the additional layers. Now I do need to use this one to right here as well. All right. Now what I am missing is how we connect, how we move this point to the next layers. So we also need to change this value here as well, which is just the multiplication of n. So let's multiply this by n. And since n starts from 0, I want to make this to start from 1. So let's make this n plus 1. Okay, and some of the triangulations are messing up. So let's try to disable this for now and just see just the points. And if the point array is at this correct position to be able to connect. Okay, so the first set of triangles right here, and the second layer we have for these point set, we have 2 points, corresponding 2 points. For this point, we have corresponding 2 points here. So looks good. We just need to connect these points as triangles. For the second set, we're going to connect the center point to create these triangles. For the other 2 points, I'm going to create this and this loop. All right. This can need to think about the structures, how we get the informations out of those array, 2 set of arrays, to be able layers. So let's just think about the second layers, right? By not considering about the first one. So in order to do that, we do need to have from the PTS1 array, we need to get 2 points informations, and from the second layer corresponding to these 2 points, we need to get 3 points, 1 2 3. So 1 2 and 1 2 3. So we need, in total, we need to have 5 points in order to create 3 triangles out of these sets, right? So let's do that inside this loop. And let's think about which loop should make sense. What kind of loops make sense to create that kind of loops? So from the second layer, we have 16 points in the first layer, 32 points in the second layer, and so in this case, the information for the second layer can be retrieved using this current divisions. So let's use this one, I think. which is equal to this one, so might be okay with this one. All right. But the total set of these 5 triangles is equal to the number of points in the first layer. So actually we want to use the number of the first layer in order to create 16 sets of 5 triangles. But the problem is if the n is equal to 0, then we only have 1 point. So that is kind of irregular. So what I would like to do is to divide the second set of numbers by 2, which should be equal to the number of first layers. Then that can be also used for n is equal to 0. And just in case, I am going to make it as a ceiling number. Okay, to make it as a integer. Right. And let's get those informations. Let's have this as a PTS1, PTS2, PTS3, 4, 5, right? I mean PT1, PT2, PT3, 4, 5. So PT1 should comes from I, PT2, I plus 1, and divided by this same length, right? Now PT3 comes from, wait a minute, this should be from PTS1, and PTS2 comes from probably I, not sure yet. PTS4, PTS2, I plus 1. And in this case, if it goes over the number of PTS2, then we just need to calculate the remains with PTS2. And I might need to use this for this one as well, just in case. And PT5, which is just adding additional 1 to this one. Yep. Oops. Spell mistake. Alright. Okay, hopefully this will do. Now that I have 5 points, it's time to try connecting those points to create 3 sets of triangles for each set. So this is PT1, PT2, PT3, PT4, PT5. Now let's do that. So we need to create 3 triangles inside this for loop. Let's call the first triangle P triangle 1, starting from PT1, PT2, and PT3, PT4, I mean. So add prim, polygon, PT1, PT2, PT4. Let's see. Oop, nope. Didn't create what I intended to have. So let's see why. I am probably having let's see why this happened. So I have been added. Okay, that should be okay. If this is wrong, I'm just, this might, let me check what this number is right now. Let's check the attribute 24. Is that correct? I don't, 24, so previously it was 48. Really? That doesn't sound correct. looks like, okay, the point number has just been added. Right. Okay, so I think I need to reset PTS2 inside this array. All right. Now I'm still having some weird errors here. It looks like the order is wrong, obviously. So let's see why. So we have PTS2, and for doesn't really seem to work for the first layer as well, so wonder why. But let me check the attribute. Okay, so the attribute now looks correct. So this should be 16. That should be okay. Now, for the first layer, this 2 points will just give you the center point. Okay, should be. So let's set the layer to equal to 1. Okay, we do have primitive. Okay, and for from the second points, for the second PTS2, we should be able to get the point for these, but it's not really getting that, so let's see why. So this might be wrong somehow. Let me check if the array itself is correct. Okay, looks correct. Yeah, the number seems correct. So I probably am doing something wrong right here. Let me first change this to an integer. Okay, like that. Okay, and so why is this? Let me check every single numbers. Sorry for debugging. This happens. Okay, let's see. So 8, okay, looks correct. How about PT1 and PT2? 0, 0, which should also be correct. Yep. So why am I having this problem? Okay, I know why. Since PT1 and PT2 shares the same points for the triangles, this doesn't really create anything. So let me try with triangle 2. Which is poly PT1 and P, so in this case PT3 PT4 PT3 PT4. Okay, and if I create another triangles, add prim 0 poly PT starting from PT2 and PT4 PT5. Didn't create everything. Not sure why. And if I increase the layers, okay, something is really wrong here. I'm guessing I am not having enough number to cover all the triangles for sure. Okay, let's see why. Okay, let me see. This should be okay. This should be correct. This should also be correct. For I might be having. Okay, so this is an angle X. So the point part looks correct, but the order seems not correct. So let's go back to the layer 1 and see what's really wrong here. Okay. So in total for this one, I should be able to have how many loops? 8 loops. 8 loops. Okay, that doesn't seems correct. That doesn't seems correct, is it? No, I think it's right. It's correct. Just for each point, I need to create one triangle and two triangle. So 2 triangle should be created for the first layers using this loop. So which is equal to 16 triangles. So that should be correct. But I am not getting the right numbers. Okay, why is that? Why is that? Okay. Okay, I think I got it. I think I got why. I actually had to multiply I by 2 because this I is for the first layer numbers, but the second layer, for the second layer we we have numbers multiplied by 2, so for each second layers I had to multiply these by 2. Okay, now that seems correct for the first layer, and if I increase the second layer, okay, looks good. Now there are some normal flips for the center triangles right here, which is these triangle 1 connecting PT1, PT2, and PT4. So let's change the order to PT4, PT1, and PT4, PT2, and PT1. Okay, now this seems good. Okay, that should do the job. Okay, it took more time than I expected, but looks okay now. So this can change the overall radiuses. Each longer edge lengths can be controlled with this one. The layer can be used to change the number of layers. As you can see, more layers you have, really thin short edges you get, but the objective here is to try to make this the same length as the one that you have in the center, and as a result you get a flower-like shape, like called hyperbolic shape. All right. So looks good. I think for the initial geometry this could be this is done. So let's go to the next step. The next step, what I would like to do is to, first of all, I think there are some unnecessary geometry, like the geometry which is area equals to 0, especially when I created the first set of layers. There are some polygons which didn't create it, which is this one. So I need to remove that by using clean. Just make sure that I don't get any unnecessary geometries. Okay, so if I check, the number of primitive had 6,120, but by doing clean, some of the primitive has been deleted or cleared. So looks good. Okay, now it's time to actually set the vellum out of this geometry. I'm gonna use the basic cloth simulation or cloth constraints to create a hyperbolic surface. But anything could be used, but I think the bending constraints and the stretch constraints is necessary in order to create what I would like to see. So I'm gonna use this vellum cloth constraints. Now I can go back to this one later, especially for these stiffness. But since I would like to have like some kind of a rubber-like bendingness, I want to kind of increase the bending stiffness a little bit. Let's try with 1 for now. If it's too hard, then I'm gonna go back to decrease the stiffness. Alright, now for these, I think it's fine. We do have a group called stretch for the stretch constraints. We have bend for the bend constraints. What I want to do is to modify this stretch constraints inside the Vellum solver over time to increase the rest lengths so that these shorter edge will become similar to what we have in the center. Shorter edge, which is these. So in order to do that, we do need to be able to figure out which constraint belongs to the shorter edge, which edge belongs to the longer edge. Alright, so to do that, I am going to set the group before I get it into the Vellum solver. By using primitive wrangle, connecting to the constraints output. And if I just see the stretch group, this is just a bunch of lines like these, and each line contains informations like stiffness, groups, rest lengths, and so on. And what I want to change is this rest length value over time to make every value equal in the last to get the result that I want. Okay, right now every rest length is different, going from the center to the outer edge. I can clearly see that the length of this edge is much shorter than this one, but by making these lengths large enough to be able to be matched with this length, it will create the hyperbolic surface. Okay, so what I need to set as an information is which one is the shorter edge, which belongs to this circle, and which one is the longer edge, which doesn't belongs to the circle layer. Okay, so to do that, I guess there are many ways to do that, but first of all, I'm going to filter the primitive wrangle with the stretch, then get the center point for the primitive by accessing to the P attribute, then try to see the length or the magnitude of this vector value, which is always equal to the length from the center point to the center of the primitive. So if the center of the primitive is right here, the edge length or the magnitude of this P should actually be close to the radius or the multiplication of radius, which has been set to this one. Okay. If it's not close to the multiplication of this radius, which is somewhere around here, then that should be the longer edge. So that's the way I'm going to filter out which one is the shorter edge, which one is the longer edge. So in order to do that, I do need to have that long length parameter being copied right here. So we'll copy this long length, paste it right here. Then let's set stretch group. Okay, so first of all, I'm going to create the magnitude of the point P, which is the length of this vector. And what I am going to do is to divide this magnitude by the long length. And if the magnitude is the multiplication of this long length, which is the length of each edge in the vertical direction, then this should be equal to the shoulder edge. But if not is equal to the multiplication of this long length, then that should be equal to that should belongs to these longer edge groups. So in order to check that, I am going to divide the magnitude, the current length from the center point to the center of this edge, then divide by the long length, which is this one. If that is close enough to the integer value, I'm going to get the fraction. Fraction is the value which is less than 1, so point something. So if this point something is larger than something like 0.9, then it is pretty much close to the integer value. So that means we can say that this belongs to the shoulder edge. If not, then that could belongs to the longer edge. Alright, let's check out. So let's try to just show the stretch lengths and color just the short groups and see if we have separated the groups effectively. So let's set this to short for the primitive. Yup, I think I have successfully separated these shorter edge and the longer edges, so that we can use it inside a Vellum solver to set the rest length only to the shorter edge. Alright, that's good. Okay, I have a comment. Why do you use clean instead of just diffuse? Oh, I don't think fuse will delete the primitive. I'm not sure. Let me see. If it does, then fuse is also okay. So it gives 6120. So it didn't really create the primitive which the area is equal to 0. So instead of fuse, I kind of wanted to make clean so that the unused primitive is gone. It's not be preserved. That's kind of a why. And what language does Houdini use? The Vex scripting is, I think, based on C language, which is simple enough to learn. I think Houdini also has Python to use it for more like interface related stuff, or using external libraries or file operation related stuff. But other than that, in terms of the geometrical operations, I think using Vex makes more sense because it's faster, because it runs on multi-thread. Okay, so this looks good, so let's delete these and give a Vellum solver. here, right here. All right, now I don't really need the gravity, so let's set the gravity to 0. And going back to the solver, or going back to the Vellum cloth, I think I do also need to set the thickness of this cloth or disc as well. Let's see where we are setting the thickness, which is this one, I think. Okay, let's check the visual light thickness. And I think the thickness right now is a bit too thick. So let's give this a little bit thinner value. 0.1 or 0.05 or something. Yeah. Let's try to set as based on your needs. For myself, I'm gonna set it as 0.05, but this could be changed. Okay, so I think everything is ready. Let's go inside the solver and try to change the rest length of the shoulder edge. Now, if you want to do it simply without using any coding or stuff, then what you can do is to use the Vellum constraints properties. And filter by using the group called short. And what I want to do is to change the list lengths, okay, over time. But I can try with just by changing the list length instantly to see the effect. Now, in order to define what's the best length for this one, I do want to bend these first layer as well, so the less length should be a little bit larger than the initial edge length of this one. So right now I don't have that information stored anywhere, so let's get that information somewhere. We can go back to the disk wrangle and let's see if I can get that information somewhere. Now this length is being retrieved when we are creating the first layer, so which is n is equal to 0. And this is where we can get the information when n is equal to 0 as well as when I is equal to 0 by getting this information PTS3 and PT3 and PT4. By connecting these points together, we can get the edge. Then by getting the point positions for these 2 points, we should be able to get the point positions for these 2 points. So that's one way to get the value. Another way is to get the value mathematically or geometrically, which is more smart, I think. So let's do that way. Since we do know the first number of divisions, and we do know that we are dividing this by 360 degrees, then we know this angle right here. So if we know the angle right here, and if we know the radius of this polygon, then we should be able to get this edge length using trigonometry again. So let's do that. Let me try to draw some sketch to wrap up my mind how it looks like. So number of divisions, and we have angles. We want to know this length, right? And we do know this length. So by dividing this triangle to 2, and we know that r cosine 2 theta, or oops, our sine to theta is equal to 2L. So L is equal to 2R sine theta. And theta is equal to 360 degrees by n. Alright. So that is easy. Let's get that information. Float edge length is equal to 2 multiplied by the long length, which is the radius, multiplied by sine of pi multiplied by 2 divided by the division divided by 2. Alright. This should be the edge length. And let's set this to the detail attribute. Set detail attrib. Now, I want to make sure that this is correct. So let's go to the detail. And right now it says 0.39. Now let's see if this is correct by getting the line informations out of the disk using convert line. Alright. And just get these edge. And try to see the length of this edge. Okay, 0.39018 equal. Okay, so the calculations was correct. That's good. It's not deleting. How do I? Okay, I think I have some problem with the keyboard. I'm pressing delete key, but it's not deleted. Weird. Alright. Okay. How can this be done on Grasshopper? Yes, absolutely. Using kangaroo physics, this can be done. My iMac spec, I mean, I'm using MacBook Pro M1 Max. Bought this January when I was in the hospital. All right, so this edge length is equal to this one, but actually what I want to have is a little bit longer edge than this one. So probably instead of just using the division as it is, I could make this divisions -1 to make slightly bigger, this edge length to be slightly bigger for this one. So that this edge will also be grown over time. Okay, so let's check what the length is. 0.41, so slightly bigger. Okay, so let's try to use that as a constant value using this Vellum constraint properties. Alright, so what I want to do is to access the detail attribute and connect that value to this one. Now, I'm not sure how I can get the detail attribute with this Vellum constraint property. I'm not sure if I can use the expressions. I'm not sure if I can use something like OP input right here. If not, I will just go to the SOP network to get that information. Nope, I'm not getting it. So okay, is this? Nope, this is really deep. Nope, pretty deep. Nope. Where is this? Okay, I'm not sure where I'm looking at right now. So probably this. Okay, what was the name of the Vellum solver? Okay, all right, so try to use this one. Okay, so let's see what happens with this setup. So what I just did is setting the rest lengths for the shoulder edge group to be equal to this value that I have set in the detail attribute, and see what happens. Oops. This is not what I intended to have. This looks really strange. Weird. Am I doing correct? Okay. Let me just delete this and set this to 0.1 and see. Nope, I don't think this is correct. I don't think this is correct at all. Let me just skip this and see what happens without setting any constraints or setting any solvers, anything. Okay, nothing happens, so that should be good. Okay, and instead of using Vellum constraint solver properties, let me try to use the Subsolver to see if I can see what really happened. I'm gonna use Subsolver with the Constrain Geometry option. Right. And what I want to get is the constraint informations out of this one, which I don't seem to get that yet. Nope. Oh, didn't connect it. Right, so let's reset the viewport and okay, let's look at the what we have for the short edges. Okay, looks like I always need to use this reset viewport. Okay, so this is what I got for the shorter edge, so looks correct. And what I want to do is to set this rest length for every single one of it to have the same value. Okay, which sounds simple, should be simple. So for the shorter edge, list length is equal to detail edge length. That's the only thing that I want to try out. So we have edge lengths, the shorter, the rest lengths. Nope. For the shorter edge, Okay, has been updated. So hopefully by doing that, I'm getting some result. Okay, now this seems to work. Now just by changing the value to the equal value in initial frame, it does create this shape already. But the change is too fast, so what I want to do is to slowly make this grow to this current situation, the current conditions, by using kind of a frame-based value. Right. So going back to the Vellum solver, I don't really understand why the Vellum constraining property didn't work. Maybe that's due to when it's been activated. Let me check again. Oh, I shouldn't have that out. I think I just did the same things, but maybe this one, activation, since the activation can only be done in the initial frame, and after that we don't really need to set the rest length, so that might be the reason. Not sure. Or the bindings, not sure. Anyway, by using Subsolver did work, so I'm just gonna go this way. Yep. And so what I want to do is to apply some frame-based value in order to grow the rest lengths from the original value to the ending value. The original value, it can be retrieved by accessing to the rest lengths orig. This is the original rest length value. So and the frame-based value can be retrieved from the frame, and I could also divide this by the end frame of the growth. And when it becomes equal to 1, then that's the ending point. So I don't want to make this go over 1, so let's clamp this to 1 so it doesn't go over 1. Okay, now I have a value in between 0 to 1 with this value. I could now let's give this as a variable as well. The actual functions could be, or actual equations could be starting from 0, or the starting from the original lengths, we could go to the final lengths in the end. And we have one parameters, which is the end of the frame to grow. So let's say if I want to stop growing when the frame is equal to 180, I type 180 here. And this should be able to give you a slow growth to the rest lengths, the shorter edge. And let's see the result. I'm gonna connect the null node to the first input the first output to see the result. Now the change is done, slowly growing over time. Looks good. And I can see that it's still growing until 180 frame. And then when it reaches to 180, it will stop growth and try to find the stable positions. Alright, looks good. This simulation seems to do well. I already have some interesting shape here. Let's try to change some constraint value like the stiffness of the bending. If I make it really hard, then it will try to stay flat as possible, which might be interesting to see. So let's see if I set this to 100 and see what happens. I kind of see more jiggles on the edges. Interesting. So by having larger values for the bending, it will try to create the larger arc to the edge, and as a result, it's creating this kind of shape. It's not really stable, but interesting enough. Ooh, that's too fast. Alright, if I make this small, really small, like the real cloth, now we are having tons of bendings instead. That's also interesting. And slow. Now that's too flexible, I guess. But still interesting, eh? So probably for my aesthetic, keeping this to 1 is fine, but playing out with these values might be interesting. Now, there are some differences by changing the initial divisions numbers as well. So let's see. By increasing by decreasing the divisions, like to 5. You get more larger like shapes or larger bendings. Bit more polygonal. Yeah. Not really smooth in the end. Maybe that's too less. But maybe stopping at this point might be interesting. So I could add some parameters when I would like to stop the growth. That might also be one set of parameter that I could add. So let's do that. Go back to the Subsolver inside, and this is going until the end by setting this to 1, but by making this as a parameter as well, like 0.5, or I mean just have to set the name here. So let's say 0.5. Then the end ratio value will be equal to 0.5, so it's not really totally going to have the same length all over the place, but stops at some point. Maybe this is still too large. And let me go back and change a little bit more. Like, let's set this to 0.25 and the frames to 100. So for the initial divisions equal to 5, maybe this parameter was good. Looks really nice. In this case, the lengths, as you can see, the lengths in the center and the lengths on the edge is not really equal. This is, I think it's more like 50%, but still looks good. Now, if I set the divisions to really high value, like 30, you have tons of wiggles. Now in those cases, I think I can set the ratio back to 1. So I don't want to go back and inside and go back and forth to double click the solver. So I'm going to create the global parameters to be able to control the values from outside. I'm going to create the null node. I have a comment: with large stiffness it can help to increase damping. I see. Good to know. Good to know. So let's store all the parameters that I can control for this setup inside here. I am going to drag and drop all the parameters that I created, like long lengths, layer, division. What else? Going inside the Subsolver and the end frame and the end ratio. What else? That's pretty much it for now. Okay. So I'm gonna set the end ratio back to 1. See what happens. More detail, since we have more edges than before. A bit slower to take it to the stable state, but looks nice. Now there is a chance to make the outer edge larger than the current edge lengths, like I mean to the center edge. So this the outer edge, like these one, could be larger than the center one. If you want to do that, then what you could do is to make this ratio bigger. I think. Is it? Maybe not. Maybe not. Maybe not. Yeah, this doesn't really give. This doesn't really give, or does it? Let me check. What did I have as an equations? I want to make the outer edge. I want to give an option to make the outer edge bigger than the inner edge. So let's see what I can do for that. Okay, so the end ratio. Yeah, this doesn't give you the option to stop. So let's see. Actually, the final length has to be able to modified. So let's apply some additional multiplication to this final length. Lengths or no, not really, because this is kind of this is not really related to the original value. So in order to change the gradational lengths, maybe also instead of using this one, maybe I should do it. I should create the lengths based on this rest original, kind of. Right. How do we do that? I got a comment. node is outside subnet when I try to drag the subparameters onto the null. Okay, that is because if you go to the edit parameter interface, you do need to uncheck this for bit linking parameters from outside the subnet. By unchecking this one, you should be able to drag and drop any kind of parameters to the null node outside the subnet. If you have this checked on, then you do have some errors appeared. I've been taught this technique from someone in the comment in this streaming some time ago, so thanks for all the comment. So where were we? Where are we? So I'm gonna try to set this back to 1 and try to change the final length somehow based on the ratio. Okay, so let's see. The final length, or I'm gonna name to the I'm gonna change this name to static lengths and name the final lengths to fit the f value to a from rest original no, I think it's not correct. Final length is based on the rest origin, and I would like to create I would like to have another parameters. Maybe this could be the parameters. Okay, so fit 0, 1 end ratio to rest origin. So if the end ratio is equal to 0, then it will just keep the original value, and if it's equal to 1, then what I want to use this static length. So static length, but if it goes over 1, then I want to make the value goes over the static length. So I shouldn't use this fit functions because it just cramps in between the source and the target. So instead of using the fit, I am going to just calculate, just create the equations starting from rest origin multiplied by plus static length multiplied by a static length minus rest origin multiplied by end ratio. Okay, so in this case, if the end ratio is equal to 1, you get static length. If it's equal to 0, you get rest origin. I'm getting the different names. And if it goes over 1, let's say if it's equal to 2, then that is 2 multiplied by static length subtract by single rest origin. So this might work, I guess. Let's try. And why am I having errors here? Why am I having errors? Am I having somewhere something wrong? Let's see why. Syntax expecting semicolon 6. Oh yeah. Oh, still not. Unexpected identifier on the 6. Final lengths. Is this wrong? Or am I using the Japanese characters somewhere? Somehow? Static lengths, did it? Looks correct to me. Oh, it's gone. Nope, it's not really gone yet. No, it's gone. What? What is happening? But it should be okay. Okay, let's try. So if the end ratio is equal to 1, then everything is using the static lengths. I want to try with the smaller divisions. So 14. Oh, I'm getting the cache here. All right. So this is equal to 1. And if I set this to smaller value, the growth should stop at some point. Yep. Looks good. Now if I set this to more than 1, like maybe 2 is a bit too big, 1.5, then the outer edge becomes larger than the inner edge, which should give a different result. Yeah, just covering all. Okay, not bad. I could set the ratio between 0 to 2. Could you not create a fall off to the initial setup based on the distance from the center? Didn't really get what you mean. Fall off. Not sure what you mean by that with large stiffness. Could you not create a fall off on the initial setup based on the distance from the setup center? I mean just using the distance from the center. Probably you could, yeah. You could do that, I think, by using the distance-based value. You should be able to do that as well. So instead of using these, I guess you could, probably in order to do that, you do want to have the maximum length as well. So that is probably pretty much the same after we have comes to somewhere around here. Yeah, but let's see that method. So in order to get the lengths, we don't want to dynamically get the lengths because the edge position is changing over time in the Vellum solver, so we do need to get those infos stored before going into the solver. So we could go to the stretch group right here, or add additional primitive wrangle to avoid the confusions. Just name it info, and what I'm gonna name is the length from the center. So I'm just gonna call center distance, which is just the length of this at P. And I'm gonna calculate this for everything. doesn't really matter which one, or maybe just for the stretch group. Okay, now I can access to this info. Now it's probably better to have the bounding size information stored as well. So bounding size is equal to get b box size 0. Let's get and set this to detail, maybe, since we don't really need to set it to every primitive, which might not be effective. Set detail attribute. Gotta name it. Right. So this is the bounding box size, which should be corresponding to the total radius of this disk. So right now the radius is equal to the diameter is equal to 16, so the radius is equal to 16 divided by 2, 8. So, and we have 8 layers, and each length is equal to 1, so which makes sense. Right. Going back to the growth, and if you want to use the distance instead of this end ratio, let me copy this one and try to change some of the stuff. So what I have as an information is the current length, I mean the rest length, I mean not the distance from the center. So how did it code? Forgot. Send distance, yeah. Center distance. Prim. And we also want to get the detail attribute, which is the bounding box informations, this one, about b box size. So box size, right. And the actual radius that I want to refer to is the b box size dot x divided by 2. Okay, now that I have these two informations, the actual ratio of the position, let's call this pf, is equal to center distance divided by box radius. So this should be within the range between 0 to 1. So I just normalized it so that it's easier to use it. Now I can use this information replaced with some things that I did here. So probably final lengths, rest lengths. Okay, I think it's okay to have this information. Instead, I probably could integrate this as an additional parameter, right, somewhere, somehow. Probably let me think. Yeah, instead of setting the constant value end ratio like this one, I could probably use this information together with the ramp parameter. to create a curve, a more flexible curve parameter. So I'm gonna add a ramp parameter to this one and just replace this end ratio with PF. And in those cases, I don't really need the end ratio anymore. So with this setup, I could have these curve, and it might make sense to keep the end ratio after all, to set the maximum and the minimum. Right. Yeah. I think. Is it? Yeah, I think so. Yeah, I think it still makes sense to keep the end ratio because this is based on the frame value. So I have just added the multiplication of this PF, right, which is from 0 to 1, and if I set the curve to this straight line goes from 1 to 1, then this doesn't give any differences. Oops. The PF stay as 1, so it doesn't really exist in these equations. So it's pretty much the same with this first setup. But once I change this curve to something like this, then then the first edge length becomes 0. The end edge becomes the final length. So that will give additional constraints to the edge length. And what's good about having this curve is that you can customize the behavior of the edge lengths using these curves. So let's see what happens. I'm gonna keep it as this straight as a default. And let's drag that information to the null node. Connect this one to here. And drag and drop. How do I name this? Center distance ramp. No, it's not really clear what that means, but just as a memo. Frame divisions, yeah. Okay, go back and okay, I'm going to keep the end ratios equal to 1, and instead of using the end ratio, I'm going to try to use this ramp parameter to try to change the lengths. So this will be the scale ratio for the edges. So if I set the curve something like this, then the edge which close to the outer edge, the boundary should have smaller edge lengths, hopefully. Let's see if that's the way, if that's the thing. Looks like it. Yeah. Think I'm getting it. Nice. Alright, now if I change this to a something like this. what would happen? So in this case, I am presuming that you have much more number of, how do I call this, arcs or wrinkles. Yeah, just as I assumed. Great, great. And I think what's good about having this curve, you can also set this to a more smooth curve and make it more customizable, something like these, which might create something really weird as a result. Let's see. Not really see the changes. I am going to try to set this to something like this. Something like that. Alright. Seeing something weird. Interesting. Okay. This is not I expected, but looks nice. Let's see it with the matte cap. Okay, I think I need to save this. Nice. Yeah, so became a bit more flexible so that you can change all those setups here. But I'm gonna keep it to the default setup for now. To the linear setup, like that. Okay. Now, another things that I want to try out, if you have still time, to change somehow the longer edge groups. Right now I was only tweaking with this shorter edge, but what if I do the similar things to this longer edge things here? I mean, initially these edges are constant lengths, so nothing happens if I set the less lengths to the same value, I think. But if I change this value over time to something different, probably close to this setup by the distance from the center, if I change the ratio of these lengths, maybe something different you can get. So shall we try that as well? Right? So yeah, I would like to do that, and for that purpose, since initial length is all the same, I'm not going to store the original lengths because you can get that. I mean, it doesn't really make sense to use the original lengths, because it doesn't really change here. So what I'm just going to do is to try to create another ramp parameter just to change the longer edge lengths gradually, small to larger or large to small, based on these curves. Okay, let's see. So I am going to create another primitive wrangle. I'm gonna call this growth short, and I'm gonna copy this one so that I can reuse some of the stuff that I wrote for the longer version. Now I haven't tried this before the streaming, so it might take some time. I do have this information for the longer edge as well, this one as well, so I can keep everything here. And I am not sure if I need this. I think I do need... do I need this? And yeah, I do need this. Yeah, this is the frame-based value. So I do need this. And the static length... No, I don't really need this one. And ratio... probably I don't really need this one as well, because the end ratio is just changing the static length ratio. Okay, so the final length is the rest length original. Oh, maybe I could keep this after all. Starting from the rest length original and multiply by PF, multiply by end ratio. I think that's it. That's pretty much it. Alright, so if it's end ratio and PF is equal to 1, then you are just keeping the long length as it is. And if the if you are changing this to something else, like for PF or end ratio, then the final length will kind of differ based on the distance from the center and the end ratio. So, and everything else, this one should be okay with the current value. And I am not sure if I can share the end frame and end ratio. End frame, I think it's okay to share, because I can set the end of the simulations to the same with the short. But for the end ratio, maybe I could make it separated. So let's delete the link and link it with a controller as an additional parameter, as well as the ramp parameter. So let's also delete the link for the ramp parameter and drag and drop the end frame, oh, not this one, end ratio, and P frame. What's wrong? Okay, it's being used. I think problem with growth long already linked to center dist ramp. Send dist ramp. Okay, I think the link has not been removed, even if I set this to delete channel. So again, I'm just gonna recreate it. Just delete this, apply, recreate the ramp. Oh, why? Why is it? I am not sure. Okay, let me go back again. So let me try to copy paste again. Probably I might need to change the name of the parameter. That might be the reason. I'm calling it PF ramp. Well, it's not having, it's not sharing the same name, so it should be fine, I guess. Let's go. Okay. Okay, so the first end ratio for the end ratio might not be the correct name, so I'm gonna name this end scale, short end scale, and this should be short short length ramp. Okay. Similar to this, I am going to rename these long and scale and long length ramp. Alrighty. And I do need to change this to long. Alright. This should do the job. Hopefully. I am going to keep the short scale to 1 so that I can see the differences. And is it correct? Is this correct? Let me see. Yep. Okay. So let's set this to 1 1 so that this will be the default value. And let's see how the default looks like. Okay, again, I'm having the caches shown up. Okay, so as a default, it looks like these. Okay. So let's see what happens if I change the ratio for the longer edge. Right? So let's try with shorter to longer by setting this to something like that, 50%. So this means that the lengths, the longer edge group lengths will become shorter. The smallest will be 50% and then gradually grows up. These edge lengths will be kept as it is because this is 200. Maybe a little bit smaller to see the difference. Let's see what happens. Now do I see any changes? It's been squashed for sure, but other than that, nothing too special. Makes it more like a ball. Okay. That's fine. Now if I make it the other way around, like that, what would happen? Making the outer edge shorter. This becomes more polygonal, more pointy. Interesting. If I raise this up in the middle of the simulations, grows up instantly. If I set the end scale to 2, okay, well, it does give you a little different result, but not really obvious what happens. Wow, it's interesting. Since the middle part becomes multiplied by 2 in terms of the edge lengths, it becomes something really unique. Okay. If I set this to a bit more customized curve, what would happen? Like going from 50%, create a wavy length profile like that. Interesting. Ooh, hoo, hoo. More like a UFO style. Okay, well, maybe I could probably start creating some creatures out of this setup. Nice. Okay, so something interesting might happen with some parameters. I'll just keep this to 1 and 1. Okay, so that's pretty much it for the basic setup that I wanted to show. Other than this, in order to visualize this a bit more like cleanly, you could add some thickness. Oop, I want to make this equal to 1. That was too fast. Okay, let's go back from the start, from the beginning. I'm going to create this final surface, something doable for renderings, and finish this streaming. If you have any like questions or feedback or any comments, please do throw. Okay, so first of all, what I would like to have as additional parameter is the thickness, which could be used as the thickness information for the Vellum constraints. So let's have that somewhere. Let's go from 1 to 0.1, 0 to 0.1. Currently for the Vellum thickness, I'm setting this to 0.05, so let's copy that information, paste that to where I was setting the thickness value. Also, I could directly use this information to visualize the thickness as the geometry. I could just use the node from the side effects labs. You do need to install this when you install the Houdini, and use that depths here. Okay, which should not have any intersection because of this Vellum constraints. That's good. Now right now this is a bit too blocky, too polygonal, so let's make this oh, Vellum post process. Okay. Yeah, actually I haven't used this one. Let's use this. Let's see. And extrude by thickness. Ah, nice. Yes, this is what I wanted. Thank you. Visualize, show collision. I haven't really used this one for myself, so not sure what kind of parameters that I could use. Cut mole, nice. Loop, yeah, loop is nice, right? Yes. Yeah, pretty nice. Gonna keep this as 1. You could also probably use noise as an additional multiplier to vary the effect. That will be interesting as well. Yes. I could probably use it over the solver, or yeah, to have additional wrinkles. That'll be interesting. Oops. Oop. Oh, nope. Okay, let me finish this with the visualizing. So instead of using thickened, as Peter has been give me the instructions, using Vellum post process makes faster. Great. And that's pretty much it. Ooh, no. Okay. Right. So other than this, you can probably the normal has been recreated, so not really need to do anything. So all the rest you can just set up your own shader, set up for the renderings, and that's pretty much it. I have a question from Ron Galvard. I am trying to create a wave tool like found in Vimeo and just copy and paste video on my channel. I was only able to create a velocity field, but I don't know how to make it move like an example. I'm trying to... I'm not sure which video you were talking about. Which wave tool? What kind of wave tool? Yeah, if you direct me to that video, maybe I can check. From argument. What is the underlying framework that makes Houdini's node system so much more powerful than others like Blender? That I don't really know. But underlying framework that makes Houdini node system so much more. I mean, everything in Houdini is being node based. Every node is being created from other node, so that's the totally different stuff from the Blender. What makes it different? Houdini really started from the node based from scratch. So, but Blender, I don't think Blender is. Blender is adding node system later as a kind of a process, so that makes a big difference, I guess. We copy from Vimeo. Which Vimeo? I see. The YouTube just delete the URL, maybe due to the spam. Well, you could probably write a URL without starting from without writing HTTP. Instead of HTTP, you could write TTP, starting from TTP to paste the URL. Maybe that way you could paste a link. Not sure if that works. So what else? Well, as Peter was saying, adding some additional noise might be interesting. Yeah. Now where can I add that? I could add it as an post process, like after calculating everything, or during the simulations as well. If I do it during the simulations, I don't really know what will going to happen. So, but using the noise for these lengths might be interesting. Yes. inside a solver with pop wind. Yeah, that might be interesting. I am not going to go through to the additional forces because that might gonna take me some more time to test out before the solver as an additional parameter. All right. Yeah, somewhere around here, I guess. I mean, I could try to modify the rest length original with the noise parameter, so that I'm going to kind of a mind bend this Vellum solver that the original length is different from the actual original stuff, but being modified with the noise. Or Peter is saying a noise on the bend stiffness may be interesting too. Yes, that will be interesting as well. Yeah, yeah, that's a good idea. I'll try that. That is a good idea, and that's easy to implement. So let's go to the bending group. How does it go? Bend. Okay. So let's change the stiffness, the bend, using another primitive wrangle. Okay. I do want to have an option without, in order to remove the noise, so I do need to set that kind of parameter as well. So let's see. Noise based on the primitive. I can just use the primitive positions with some smoothness. Right, and some scale. And if the scale is equal to 0, then that's the case. I am not adding any value. Is that it? Yeah, let's say that that's the case. Okay, so let's try with some random values first. Then so I gotta set the group to bend, and then what's the stiffness? Let me check. Stiffness is, in order to add the stiffness value to the bending, I do need to know the range, I guess. Right now it's equal to 1, but there might be a chance that I am setting different range, so I think it makes sense to add the range. This could be the range itself, scale. So yeah, probably something around here makes sense. And I would like to have the value in between 0 minus from negative value and positive value. So since noise value will create a value in between 0 to 1, I'm gonna subtract by 0.5 first, then scale it by some actual scaling value. This doesn't have to be equal to 0 to 1, but could be any range. And I am adding stiffness with this noise. Alright. And I can't really define how the noise looks like, so let's try to see it with the color to check out how it distributed. Just get the bend and try to color the primitive based on the stiffness. And that is from, not sure, -2 to 2, I guess. And change the color to something different. Okay. Am I getting the right value? Stiffness. So, wait a minute. All right. Everything yellow. Stiffness, no, okay, stiffness is not really changing. Stiffness. Okay, then I must be doing something wrong here. Noise. So it's using for the bend. If I scale this up. Okay, nothing is really happening. Am I getting the right correct value? Noise. Okay, nope. Where is it? Nope, I don't. Okay, I see it. Okay, I do have some value, and it is being added to the bend, but it's not being added to the stiffness. Okay, so I guess I'm doing something wrong here. How come? What? Okay, I am missing equal here. All right, now I see some color differences. To check, I'm gonna say -1 to 1. No, stiffness doesn't go to negative, I guess, so 0 to 1. Right. And okay, gonna go something like this. All right. Let's see with this setup. So some part you have smaller stiffness, some part you have larger stiffness with this setup. Let's see what happens. Don't really want to show up the Vellum's process because it's gonna make it slower, I guess. Alright, show up the edge. Display. Not really sure what's happening here. Maybe I should increase the base stiffness a little bit. Maybe to 10. And also bend noise to 10 as well. Or maybe that's too much. I'm gonna make the base to 5. Alright, let's see. Yeah. Now that is interesting. Alright, well, something weird. That might be too big. That might have been too big. Let's set this to 2. And let's set the noise to 4. Maybe smooth this a little bit bigger. Wow. Okay, it does give something different from the previous setup. It's pretty interesting, but it's not really clean. Maybe I could still set the stiffness from 1 and then just keep the bend stiffness a bit bigger. And there might be possible that stiffness becomes 0 at some state, but let me see. If I set this to 0, what? How come it's becoming so fast? Am I doing something wrong here? If I disable this? Okay, it's become a bit too fast. I'm not sure why. Not sure why. Why did it becomes so fast? Shouldn't be that fast. Looks like everything is being initialized instantly. Now why is that? Why is that? Scale is 0. Ah, wait. Which scale? Did I set something wrong here? Currently I'm disabling this one. Huh. Let me see. I think I am getting something that shouldn't happen. Let's see why. Huh. Okay, well, obviously it's increasing the longer lengths instantly somehow. Which shouldn't happen. Which shouldn't happen. Why is it? What if I disable this one? Oh. Okay. Since I'm making the growth really slow, so and last time it was working, so I don't think I need to raise up the constraint solver number. I think something is wrong. Is this one? Maybe this one. Yeah, maybe this edge length thickness might be doing something wrong here. Let me check. Maybe not, but I'm not sure. Maybe if I set this to 001 to make it small enough. Wow. Oh. Wow. Huh. I wonder why. Wonder why. Let me check the current rest lengths. What did I do wrong over time? Okay, so the rest lengths. Just going to get First of all, I'm gonna check the long. Obviously, everything is growing up. Somehow. Rest length original. But the rest length is the same as the rest length original, which is pretty much equal to 1, so that should be okay. Then check bend stiffness on the close constraints. Yeah, that might be the reason. I'm gonna set this back to 5 and the bend stiffness. Oops. Yep, that was the reason. Made it too high. Yeah, that was the reason. Sorry for that. Okay. So although doesn't really look like the same stuff as I had last time, is it? Bend. Did I change anything here? I don't think so. Not really sure what I did over time to make these things. I don't know, if I make this the 0.1. Huh. What if I don't have this compression stiffness? Nope. Nope. The change is pretty drastic somehow. Which I didn't really intended to have. Might be due to this one. What's wrong? What is wrong here? Gonna get the short edge length and check the result. Okay, somewhere on here, get the short, and yeah, obviously something could be wrong here. Now, I think it is gradually changing. The value is gradually changing. So I don't see much problem here, but looks pretty large. There's a result. I might have changed the stretch stiffness too big. That might also be the reason. Stretch wide. Wait a minute. If I set the Vellum constraints, maybe I made this too small instead for the stretch. I should have changed the bend constraints, but instead I think I have changed the stretch constraints. That might be the reason. Let's set the default setup. Yeah, 1 times 1E10. So I guess that's the reason. And what's the bending? The bending, I just think that's fine with this. Okay, hopefully this will solve the problem. There you go. There you go. Sorry for that. Now it's time to test the noise on the bend stiffness. Alright, finally. Somewhere on here. These gradations. I think I did something wrong. What? Why am I getting this error here? Reset. Okay. Okay. Have I said everything? Think so? Yep. Think so. Now I am changing the bending stiffness. I'm not sure if I see the differences. I probably gotta make it more drastic in terms of the change. So more bending stiffness you get, harder to bend. So probably might make more sense to use the noise itself as with the minimum and maximum as the constraints. Let's do that. And if I set the minimum and maximum the same, then you get the constant like stiffness, so that make sense. Min stiff max stiff. All right, and the noise, I am going to get rid of this scale, get rid of this minus value, and as a result of the noise you get a value in between 0 to 1, but most of the time the value is in between 0.3 to 0.7, somewhere around that. So considering that, I am going to set the final stiffness to from 0.3 to 0.7. I'm gonna remap it to minimum stiffness and to maximum stiffness, and just use it as it is as a stiffness value. Now the minimum, I'll try to make it not too small, so 1. Maximum 10. Now that's more easier to control, I guess. And I don't really need a scale parameter, so let's remove. See what happens. First thing I gotta make sure that if the constant change is also alive. So if I make this 10, 10, then all the stiffness should become equal to 10, meaning the roundness becomes larger, but doesn't really make any changes, I think. Maybe I'm doing something wrong here. Let's check the... Okay, it's not really changed. What? What? I'm using the bend. I'm changing the stiffness. I'm using the noise value. And the stiffness is not being changed. Where did it go? It should be equal to 10 in this case, but not. Okay, gotta make sure if this noise is alive. Okay, so I do have this noise value, and I realize I didn't use this one as a final output. Stupid me. Why can I be so dumb? Alright, so this should be fine. So currently I'm using the constant 10 as a stiffness for the bending, and which makes the size of the arc really big, as I assumed. Now by mixing with the smaller value, what would change? What would do? What will happen? I am probably seeing some variations, but not really sure. Maybe I'm getting too tired. But looks interesting enough. Let's say this is okay, since this should be working. I'm just going to add this as a parameter. I mean, people who are watching this could just give a try to add additional parameters by yourself and see what can be done additionally. Let's give this to somewhere around here, somewhere in here, somewhere here. So if this value is the same, then this will be used as the constant. Okay, getting a lot of parameters. Alright. And alright. Sorry, I wasn't watching the comment. Let me look back. May need more constraints, stiffness scales to clean up the edges. Check balance. Thanks for all the comments. Sorry, I did one stupid things to mess up. What I did wrong is to set the stretch constraints equal to 1. That was the problem. Okay, wrong. Give me a search term. KA wave tool. Let me search for it. Okay, so this is the thing. Interesting. I'm not sure how it's being done, by simulations or some geometrical calculations, maybe simulations, I guess. Using some kind of a vector field. I don't know, is it using together with the flip tool or something? Not sure. I do see this vector field. I'm not sure if it's just a visualization or use it as an input. If it uses as an input, that'll be interesting. If it's just a result, then maybe I cannot do anything for this. Well, I will look into this and see if I can figure out how it's been done. If not, I'll give a white flag for it. Okay, any more questions or feedback? That would be great. I mean, I already got a tons of great feedbacks, and I'm really grateful for that. So that thank you very much for that. And all the results that I make today will be uploaded as a file you can download for free from a video description page from this YouTube video. I'll paste the link as soon as I finish the live stream so that you can download to check it out. I'm also posting the same file to the Patreon page, so if you are kind enough to support me, that would be great as well. You can also download from that as well. Okay, any more questions? If not, I guess it's probably time to go sleep for me. I'm gonna set this to default value before saving it, so that everybody can tweak from the default setup, then go for more customizable stuff. I mean, okay, well, thank you very much, everybody, for watching and all the great comments. I really enjoyed tonight. Yep. I hope to see you sometime next week as well with some kind of a different topic, and hope to have you guys as well. Yeah. So that's it. Good night and have a good day to you from Japan. Night.